This is section 252, and we're going to take a look at systems of nonlinear equations. More importantly, we're going to solve these systems of linear and nonlinear equations. And we're going to use what we call the substitution method. Now, there are two ways to solve a system, both the substitution and the elimination method. Now, this method we are going to examine later. Right now, we are going to focus on the substitution method. Now, the theme that we need to get from the substitution method is that you take what a variable equals and you plug it into the other equation. So let's look at this first example here. I have y equals x squared and y equals 8 minus x squared. We know what y equals. So we can actually take that value. Because I know y is x squared, that means that in the other equation, I can replace y with x squared. Because we're saying y is x squared, so I can plug in x squared into y. Now from there, we just examine what kind of equation it is. So x squared equals 8 minus x squared. Okay, that's quadratic. Okay, let's combine the x squareds together so I get 2x squared. Oh, I only have an x squared. Okay, I can divide both sides by 2. Now I can square root both sides. So you get x equals plus or minus 2. But I only found what the x equals. If you notice in the original equation, I had both an x and a y. So now I need to find what the y is. So now I need to take that x and I need to plug it back into the equation. And so if I plug x back in, I plug it in for x, both the positive and negative 2, I'm going to get 4. 2 squared is 4, negative 2 squared is 4. So that means when x was 2, y is 4. When x is negative 2, y is positive 4. And so those are my answers. Now we write our answer as a point because let's look at it graphically. What if I put this into Desmos? What we just found are where these two equations intersect. That's the solution. The solution is where these equations intersect. That's what we're looking for, and we're finding that algebraically. And so they intersect at these values here. Now, a very common question. Mr. Duvall, in the last lesson, we only paid attention to the x values. Why is it that in this lesson, we're writing both the x and the y values? Well, in the previous lesson, if I said something like this, if you notice, there's only one variable. That is why we only found that one variable. But in this, we have both the x and the y. So that's why we are finding both the x and the y. And because there's both an x and a y, it's a relation. How do we express a relation? We express it as a point. Let's look at another one, a little more complicated. We don't have a variable by itself, but if we don't have one by itself, we can get it by itself. So using that top equation, I can subtract x on both sides. And I get y equals 1 minus x. Now, what does that mean? It means I can take what y is, 1 minus x, and I can plug it in for y into the other equation. Now, it looks a little messy, but let's just parse it bit by bit. That 1 minus x squared is the same as 1 minus x times 1 minus x. We can go through and we can distribute. And so that's going to give you 1 minus 2x plus x squared. Bring down the rest. Now it's quadratic. I can combine like terms together. So x squared and x squared is 2x squared. And because it's quadratic, I want it to equal 0, so I can subtract 13 on both sides. And so now, notice there's a 2 in common, so I can divide everything by 2 since we're solving and I'm going to get x squared minus x minus 6 equals 0. A times c, right? Factors of a times c that add to b. So negative 3 and 2. So I can break apart negative x into minus 3x and 2 and do factor by grouping. And when you factor it, set each equal to 0, and you get x equals 3 and negative 2. Now we just need to find the y. This is the hard part, right? We just did the hard part right here. Now we just need to plug it back in, the easy part. So if I plug in 3 and I plug in negative 2, subtract 3 on both sides, I get y equals negative 2. For that negative 2, add 2 to both sides, I get y equals 3. So when my x is 3, my y is negative 2. And when my x is 2, my y is positive 3. Let's look at that visually. See, we found these points here where they intersect. So what did we learn today? We learned how to find the system of non-linear equations, and we used the substitution method to do it. This does conclude our lesson. If you have any other questions, please leave them in the comments.